Assalamu alaikum. In this project, yes, we're going to be blinking multiple LEDs just like I showed you before. So what you will learn, use TinkerCad to simulate circuits, write C++ code, use for loop statements. You'll need a laptop and Wi-Fi. So first, let's create a simple circuit using an LED, a resistor, and connect it to pin number 4 of your Arduino. We're just going to be using simulation. So I'm going to go over this code with you just quickly. So you're going to be using block codes. And then later on, I will show you how you can convert the block code into a C++ code, like on star. In C++, we will have a void setup, and then we're gonna basically assign a mode to that pin, and the pin we choose is pin number 4, and we're gonna make this pin as an output. And then in the forever block, the counterpart on C++ is a void loop. So this is a loop, and in the visual block codes that you have here. So basically we set pin number 4. Basically we just say digital write pin number 4 to high. And that's this statement here is exactly this statement here. The wait is the delay on C++. So we have wait 400 milliseconds. So in C++ we just write delay 400 parentheses, and we do semicolon as I explained before. This is just whatever comes after the forward slash, you just comment basically. And then again, this statement here, or this block code, set pin 4 to low. On the C++ side is digital write, pin number 4 between parentheses. So we have digital write function have 2 arguments. The first one is the pin value, which is 4, and then we're going to make this low. So we're going to turn on an LED and turn it off. So let's see this in an actual code. Once you open TinkerCad, go to circuits, and I want you to create a new circuit. So I will need an Arduino. I'm going to type Arduino. Drag it here. Breadboard. Let's choose a small one. And then I'm going to need an LED right here. So just drop it anywhere you like for example here. I'm going to need a resistor right here. Let's use 220 ohms. Okay. So we're connecting pin number 4 to our resistor. Remember, as I mentioned before, that the longer side of the LED is the anode. That's where we get the plus. So we're getting a voltage from here, going to the resistor, coming out from here, and going to the anode. And we're going to connect the cathode, which is the other leg, the shorter leg, this one, to the ground. Okay. So to connect this to the ground, we can just go from here, there, and we have ground here. We can just color this in black, for example. Okay, and we can make this black also, and then just color this in red. Okay, so now we connected. We have a closed circuits. Current is going to come from pin 4. It's going to go through the resistor, through the LED, and back to the ground. So it's closed circuit, so no problem. Now we can code. Once we have closed circuits, then we can code. To code, basically, you just go here, and it's already just like the Arduino. We already have that set up and just like on the Arduino, we have setup and the void loop. Here we have the on star and forever. So that's a loop, and this is on the setup here. We don't need to set up anything except maybe we need to change this code. We just build a new code. So what we need, we don't want the built-in, since we are not using pin 13, we're going to be using pin 4. So we're going to set pin 4 to high. Then we're going to go to control, and we're going to change that delay, which is wait, and they just choose millisecond, and we're going to put 400 millisecond here. You can keep second, you know, it's not a problem. We can just click, or we can go back and grab the set pin again. I'm just going to go and duplicate, make it easy. Now I can make a pin low to turn it off and delay 400 millisecond. And this is a loop. So once it hits in the bottom here, this is like the brackets, the closing brackets, and this is the open bracket. So once it gets here, you go back here, it runs this code, it comes back. This is a forever continuous loop. All right, let's do simulation. So let's go do the code. Okay. So it's working. In this exercise, we used block code. If you go to under here blocks and go to text, so it's going to give you a message that basically you will convert this block code into text. Just say yes. So now you have basically your C++ code. That's the counterpart to that visual block code that looks like Lego like. So now this you can actually use text like this and program Arduino instead of visual once you become fluent with C++. So in this, we're gonna in the next exercise, we're gonna use, instead of visual code, we're gonna use this type of coding, okay? Where we're gonna go to void setup, we're gonna assign pin 4 as an output, but this time we will have like 5 LEDs instead of only 1 LED. So we'll have pin 4, 5, 6, 7, and 8. We all have to copy this, copy and paste, and so each pin is gonna have this code here. So for so each pin is gonna have the same code repeated. So let's do it. So you're gonna, as I mentioned, we will have 5 of these. So one is here, another one is here, another one is here, and the other one is here. And go ahead and connect it. I'm gonna connect them and arrange the wires. So after arranging all the wires, now we have 5 LEDs instead of just 1 LED. Okay, so LED 1 is connected to pin number 4, and LED, this one, the 5th one, is connected to pin number 8. Okay, so do the same thing. Now I want you to go back to the code, and now we're going to be using, as I mentioned, we're going to be using text code just like before, the same way where we set up a pin 4 as an output. Now this time, instead of keep writing the 400 millisecond, I'm just going to name it. I create a variable called timer, okay, and then I will be just using for my delay. I just say delay. Timer means delay 400 millisecond. So this one is going to repeat it 5 times here, and that same code is going to be repeated 5 times, okay, but each time we're going to change the pin number, as you see, and then we're going to run the code. We're going to run this code here. Then we're going to run this code. So it's working. We could have done it better, we could have done this code better because this is too long and we can make a mistake, it's a long code. So now we're going to look at if there's another way of, without repeating this, if we can program these 5 LEDs to do the same thing. Yes, there is. We're going to be using for loop statements. Let's go and see how it's done. In the for loop statement, so basically we don't repeat these codes, but we're going to be using this statement called for. So we're going to initialize a variable. We're going to name variable this pin, could be any variable, any name you want. And we're going to set it to 4, so it starts with number 4. This pin, since we're using until pin number 8, so until we reach 9, strictly less than 9, okay? And then we're going to use this pin, that the same variable, and we increase it by 1. When you do this pin plus plus, means you're going to increment that variable by 1, okay? And then we just use the same pin mode statements. Pin mode, this pin, we have to, basically, instead of putting pin number 4, 5, 6, keep changing, know that variable is going to be increased. So the first time is 4, we're going to increment it by 1, it's going to be 5, and then it's going to be set as an output. That's how basically this for statement works. Very easy, okay? We're going to use it to set up our pins, and also we're going to use it in the loop function as follow. So we're going to do the same thing. For, this is the syntax. You do for just like here, for, and between parentheses you put 3 arguments. You put the variable right here, which is the initial value. It's 4, it's an integer, and it starts with 4. And then we're gonna be the condition, as long as we didn't reach 9, we keep running. Okay, we keep incrementing this variable, and then we do semicolon between each argument, and then here we increment this variable. We close parentheses. So basically, this is the for loop, the same thing. That's what we did here. Okay, and then we execute this. For the for variable here, we execute this code, and here we're going to be executing this code here. So we're going to basically turn on the LED. We're going to delay for 400 milliseconds, and we're going to turn off the LED. Okay, and we can do the same thing by reversing. This is basically to go. We're going to increment from here to here, and then we can go from here. We incremented 4, 5. Each time we increment by 1, 6, 7, 8. Then we can reverse. We can go from 8, 7, 6, 5, and 4 before we reach 3. So, the same process. So if we go and start simulation, notice it's working same way, except this code, which is not using the for loop statement, is very long and it's immune to make a mistake. And the other one, it's not bad. Sometimes, let's say you have 1,000 pins. So are you going to be writing 1,000 pins? But this, it will just keep incrementing that variable as we did here. We increment this from 4 until it reaches this statement, and then basically it stops. So, this is basically the, I just wanted to show you this for loop that you can use in your programming. Okay, try to use it. It's very useful, and it's very, very used in the programming world. Thank you.